Hi everyone, my name is Shilin. Together with Baokang, Shun Yu, and Bungkit, we'll be presenting on telemarketing's campaign prediction. A Portuguese bank has been using telemarketing campaigns to promote their term deposit. They make phone calls to their customers and sell term deposit with an attractive rate. The response of the telemarketing campaign were collected. Now, the management is reviewing the performance of the telemarketing and looking to improve the success rates and hence the ROI of the telemarketing expenses. So, to achieve this business goal of improving ROI, we will be focusing on how to improve the success rates. To do this, we will first evaluate the effectiveness of telemarketing campaign on term deposit. Second, to identify the profile of term deposit campaign takers. And lastly, to predict if the client will subscribe to a term deposit. The dataset used is from a Portuguese bank. This dataset is publicly available from UCI's website. It contains the telemarketing campaigns carried out from 2008 to 2010. It has over 40,000 rows with 18 attributes. Of the attributes, they are customer demographic related, such as client job, client age, financial status info related, such as bank balances, housing loan. It also contains response from the telemarketing campaigns such as contact, last durations, campaign periods, and lastly, our targets variable whether the customer took the term deficits.
Hello everyone, my name is Yu. In this project, we use the SEMMA methodology to carry out data mining related work. It provides a structured approach to data mining project that involves a systematic process for identifying, analyzing, and extracting variable insights from huge datasets. There have five phases of SEMMA process. It's represented as import, explorer, modify, model, and access. In this project, we focus on the first three processes. The first phase is simple, which involves selecting a simple dataset for analysis. We identified a dataset on the term deposit state of the bank customer. Variable rules and the measurement level are then defined. The second phase is Explorer, which involves exploring the data to identify patterns, trees, and relationships. In the Explorer stage, we will perform univariate, bivariate, and multivariate analysis of the data. The third phase is Modify, involves cleaning, transforming, and enriching the data to ensure it's ready for analysis. This step includes dealing with missing value, outlier, and other data quality issues.
Hi everyone, I'm Baokang. I will continue to sample part. To begin our analysis, we need to convert the dataset from Excel format into SAS format. After creating a project and diagram, setting up a library, specifying the source data, and converting the Excel format into SAS format, we can get this table to show detail of variables. Those variables can be categorized into numerical data and character data. The basic setting of a system automatically assigns the measurement level for the metadata based on attribution of variables. In the default basic setting, the data types were categorized as a nominal and interval. However, some numeral data was classified as intervals, while character data was classified as a nominal. To address this issue, we are using advanced setting which allow us to redefine the data types as a binary, interval, and nominal. In the advanced setting, the system also automatically identifies the role of a variable as an input or time ID. Although most of our metadata setting was correct, there are still some errors where the data type did not accurately reflect the dataset. Therefore, manual adjustments were necessary to modify the data type. In the reflection of the role and the level of a variable, we have distinguished four measurement levels: specific, binary, interval, ordinal, and nominal attribution. Above is the reverse content. This modification reflects the final sample result that we have done.
Hi, I'm Bunket. Let's continue on the exploration of data. From my part, I will be covering on the summary statistic, univariate analysis, and also for the bivariate analysis. First, we go for the summary statistic for the continuous variable. In here, we can see that all the continuous variable there is no missing value, but the interesting part is for the variable day is the only one with the skewness value smaller than 0.5 or negative 0.5, but somehow all other continuous variable have the skewness value greater than 0.5, which is indicating which the positive value indicating these variable are positively skewed. And for the summary statistic of for the categorical variable, we can see that it's the same here is all the categorical variable, there is no missing value in here, but for the mod percentage, which is the mod value, the percentage for the mod value, most of the variable are having the mod value greater than 50%, which is the indicating the variable are imbalanced. So we might need to perform the downsampling or the upsampling for the variable. And going for the univariate analysis for the continuous variable, we can see that we show in the histogram most of the variable they are positively skewed as expected when we sawing in the summary statistic, but there is also the outlier in here in the circle part. And for the histogram or last contact date, we can show that the the distribution for the plot is bimodal, and for the last contact date of the month is a trimodal distribution in here. And it will be clearer in the box plot diagram. In here we can directly clarify where is the outlier in here. Just only the last contact date of the month, there is no outlier in here. And coming for the exploration univariate analysis for the categorical data, we first going for the binary variable. In here we can say is show that all the variable here is clean, but somehow it's just only the imbalance issue. And coming for the nominal data type is there is no missing value in here, but somehow it's still the same issue for the imbalance data. And for the ordinal data, there is also the same issue. There is the imbalanced data in here. And coming for the bivariate analysis, we can show that most of the variable are there is difference in between the across the y the target variable, but somehow in here is the balance. There is interesting to showing that there is outlier in here. We can trying to remove the outlier if there is valid reason and see that whether the balance variable is really that is really in make difference in this, because we can see in here the mean value in the balance, it seems the same, indicating the variable balance is not affecting to the target variable. And for the categorical data in here, we can see that each of the categorical is difference. There is a difference in the mode in between of the group of target variable. And it's also shown in the bivariate analysis in here. The balance variable is the only one with the probability value greater than 0.05, which indicating the balance variable is not affecting to the target variable, and it might be removed after this. And for the other bivariate analysis, most of the first going to the education versus job is quite different. This bar chart indicating that the there's difference between there's statistically difference in between for the education and the job, as well for the marital status and the loan, and also for the job versus loan. And for the others, the mean of balance versus loan, there's also a difference in mean, and as well for the others variable in here.
After exploring the relationship between two variables, there is also a need to explore relationship between the multiple variables. From the left side, there is a 3D scatter plot graph, regardless of each customer with high or low bank balance. They tend to have the house loan. Customers with a higher balance in the bank are between 20 and 50 years old, may still be working, and so they have the ability to pay the loan. Therefore, people with a higher balance in the bank tend to buy housing loan compared to customers with a lower balance in the bank. The right graph shows us, regardless of whether they have the personal loan or not, customers with a high or low balance in the bank, they tend not to subscribe a term deposit in bank. And at the same time, they tend not to have a personal bank. At the left graph, we can see the customers who choose to subscribe a deposit in bank are mostly management and technician. At the same time, customers who in these two jobs also have the most balance in the bank. Similar the previous conclusion, no matter what the job, the customer engage or how much balance they have in bank, they tend not to subscribe a term deposit in bank. Having explored the relationship between job and balance we want, if education is a main factor affecting job and bank balance, what is the relationship between job and balancing a bank and education? From the right graph, we found a customer with a higher education, especially the tertiary education, have the highest balance compared to other education levels. At the same time, in the same graph, the customer with a larger balance in the bank are management, and most of them are tertiary educated. Metric correlation analysis involves examining the relation between multiple variables to measure the level of association between them. The analysis assesses the correlation between two or more variables, with the degree of correlation represented by color range from red to blue. Blue box indicates a low correlation, while red box indicates a high correlation. Correlation value exceeding 0.9 are removed to avoid any potential bias. Based on the provided graph, there is no correlation value exceeding 0.9, indicating that there is no variable need to be removed.
The next part is the conclusion. After we revise the dataset, there are 18 variables in the dataset, including 4 binary variables, 7 interval variables, 5 nominal variables, 1 ordinal variables as input row, and 1 interval variables as time ID row. During data exploration, we do not find any missing data or inconsistent data, but we found noisy data in the dataset. The noisy variables are campaign duration, PDs, and dates. After this phase of work, we have 2 objectives are proven. For the first objective, we have the following key findings. Firstly, they only have 11.7% of clients decide to subscribe to the term deposit offered by the bank. By the median and mean of the client's last contact duration, we can find the majority of the clients are not interested in the term deposit offered by the bank. The above statistics indicate that the telemarketing campaign must have been less successful, where majority of clients are not subscribed to the term deposit offer. For the second objective, we have the following profile of term deposit campaign takers. Firstly, the average balance of bank customer does not affect the decision of a bank customer to subscribe for the term deposit. The number of days since the customer last contacted can have a significant impact on the amount of time a bank customer subscribes to a term deposit. A client's marital status, education level, credit default, housing loan, personal loan, contact information, last contacted, and the result of previous marketing campaign all show big difference between the group of bank clients subscribed a term deposit within each category in respective variable.